Integration by partial fractions. What is integration by partial fractions? Well, the partial fractions method is used to integrate rational functions. And what we'll do is take a simplified rational expression and split it into the sum of two or more simpler fractions. The technique by which we split the rational expression is called partial fraction decomposition, and that process is detailed in a previous presentation. So we want to integrate using partial fractions. Okay. We start with some rational expression f over g, and we want to do the following. We'll first factor g, rewrite g as the product of some p times q. Then we'll rewrite our original expression as some unknown a over the first factor of g, plus another unknown b over the second factor of g. And then we'll use algebra to figure out what the values of a and b are. This three-step process is the partial fraction decomposition process. Again, that was detailed in a previous presentation. So then we want to evaluate the integral of f over g, which then would be the same as evaluating the integral of a over p plus the integral of b over q. And our goal is for those two partial fractions to be simpler integrals to evaluate than the f over g expression that we started with. So let's look at our first example. We want to integrate 3x plus 27 over x squared plus 11x plus 28. So to start, we have to factor that denominator and then rewrite our integrand as the sum of partial fractions. So we factor x squared plus 11x plus 28 as x plus 7 times x plus 4, and then rewrite that as some unknown a over the first factor x plus 7, plus another unknown b over the second factor x plus 4. Completing the partial fraction decomposition process, we find that the coefficients of a and b are 5 and -2. So we know that we can rewrite 3x plus 27 over x squared plus 11x plus 28 as 5 over x plus 7 plus -2 over x plus 4. So now I want to integrate those two partial fractions. Okay, I'll start by moving the constants out front. Then I'll use substitution and find that the integrals are 5 times the natural log of the absolute value of x plus 7 minus 2 times the natural log of the absolute value of x plus 4 plus my arbitrary constant. So in the end, the value of my original expression I found by integrating two simpler partial fractions, and then I arrived there at my final answer. Our second example, we want to evaluate x plus 6 divided by the quantity x plus 2 squared. This is an example in which we're said to have a repeated factor in the denominator because of the square. So we'll rewrite that integrand as a sum of partial fractions that uses a linear factor x plus 2 to the first power and the quadratic factor x plus 2 to the second. We'll complete the process of partial fraction decomposition and find that the value of a is 1 and the value of b is 4. So I know that I can rewrite x plus 6 over the quantity x plus 2 squared as follows. Now I want to use substitution to integrate these two partial fractions. And in doing so, I end up with the natural log of the absolute value of x plus 2 minus 4 divided by x plus 2 plus my arbitrary constant c. Therefore, in the end, I was able to rewrite x plus 6 over the quantity x plus 2 squared as two partial fractions, 1 over x plus 2, 4 over x plus 2 squared, and then I arrived at my final answer, the natural log of x plus 2 minus 4 divided by x plus 2 plus my arbitrary constant c.